All right, I cannot talk over you guys. Okay, so we're gonna start with Aiden. Thank you. All right, so we're gonna start with finding limits graphically, numerically. Okay, so there's a few different perspectives. Those of you guys in math, we're gonna go through this all really fast. So today we're gonna try to go through as much as limits as possible. We're gonna have a test about limits soon. I don't know when, but yeah. So so you guys know, how do you find limits as x approach to 0 of x over square root of x plus 1 minus 1? Okay, so do you guys remember how to do this? All right, so L-Hoptol has a limitation, and we didn't talk about L-Hoptol rule until the end. There was a reason why we didn't talk about that. Is when you evaluate limits, there was a few different ways. So there are numerically, and there are graphically, and there are algebraically. So there are a few different ways, right? So you can do it numerically. How do I do it numerically? I just plug in a value. I can say, well, x over root x plus 1 and minus 1 like this, and it's gonna get this graph. And I cannot talk over you guys. Hey, either you're doing the math problem for competition, or you copy down the notes. Either way, like I'd rather you guys know and stuff. So 0. So how do I approach 0? So you can approach 0 by negative 0.1, and so I'm gonna say, well, I'm gonna change that to negative 0.11 or 0.01, and negative 0.001, like this. This is called numerically. Just plug in a number until you approach it, right? Or here we're gonna do from a positive perspective, it would be 0.001, 0.01, and 0.1. And so ideally, if you say let's go and plug in 0, if I plug in 0, it's gonna be undefined. So then you can reach that by plugging the value slowly until you get there. Now, this is, of course, is not very practical because on your AP exam, you're not going to have a calculator that you can plug in. But ideally here, it's going to give you a open circle. When you come to here, if you look at this thing here, come to here, it's going to give you an open circle. That's why it's undefined. But in math, we don't call it undefined. We call it indeterminate. Okay? So when you have 0 over 0, it's indeterminate. So we already did the numerical approach. Check. You can plug in number until you get very close to it, right? Graphically approach. Well, we can look at the graph. So we're going to look at the graph again. It seems like approaching 2. So we can say that's approaching 2. And they both have to come out the same value. They both have to come out from the left and right has to be exact same value. And if they don't come in the same value, then limit does not exist. We're going to talk about that later. Are we okay here so far? Now, graphically, we're done. Algebraically, it's something that we're going to pay attention a little bit more. But before we get there, we know that this is equal to 2. According to the first two ways. We haven't talked about algebraically. We're going to talk about algebraically later. Okay? Got it? When this limit does not exist, limit does not exist at a few situations. Can you recall when this limit does not exist? The whole limit does exist at whole. We just proved that limit does exist at a whole. It could be a jump discontinuity, but how would I written it in math? How do I written limit does not exist? Yes.
Limit x approaches positive infinity does not equal limit x approaches negative, or the negative of that x.
I think you know what you're trying to say. Instead of infinity, it'd be limit x approach to a from the left of f of x does not equal to limit x approach to a from the right of f of x. That means limit does not exist. Is that okay? So that's the one of the case. There was a second case and there's a third case, but we're not going to talk about that yet. We're going to talk about when's limit does not exist. One example is like this. Do you guys remember the graph of limit as x approach 0 of absolute value x over x? Do you guys remember what a graph of x, what a graph looked like? If you do know, no, that's wrong. What would be absolute value x over x graph look like? What?
So it's going to equal 1.
I know Nathan knows, but I know any of the rest of people to know. Which was which? Yes, that's right. So the reason why is I'm going to tell you is there is a definition of absolute value. So last year we didn't talk about this too much, but definition of absolute value. And the reason why you have definition of absolute value basically just saying if you have absolute value x, you can change the piecewise function. And that piecewise function is going to be x when x is greater than 0 and negative x when x less than 0. So in this case, that absolute value x over x can rewrite as a piecewise function. And this one's going to be x over x when x is greater than 0 and negative x over x when x is less than 0. The reason being is this. You should have two absolute value here. You should have the graph of this. And you should have graph of this. Right? And this is going to be positive x. And this is a negative version of that. So if that, I can rewrite as 1 when x is greater than 0 and negative 1 when x is less than 0. So the graph is going to look like something like this. Like Aiden's saying, it's like this. Because 1 on the right side, negative 1 on the left side. Now, according to this, if you understand graphically, do you know what's limit x approach 0 in this case? Anderson? What'd you say, Anderson? Does not exist. Why? Limit x approach the 0 from the left does not equal limit x approach to the right. It does not equal each other. So what Wesley says is a whole is limit does not exist. It's not true. You can have a whole, you can have like this, and you have whole in between it, like this, limit still exists. But this is the things that limit does not exist. Does that make sense? So therefore, that's going to give you 1, negative 1. Now, definition of absolute value is very important because sometimes you can have this absolute value x minus 1. So that's going to be here. That's going to be x minus 1. And here is going to be negative version of x minus 1. Make sure of that because a lot of problems require this. Got it? Okay. What would be a second situation limit does not exist?
There's like turns.
No,
No.
that's called differentiability. Yeah. What's the second case limit does not exist?
Like oscillation.
Oscillation's one of them, so that's the third one. And what is the second one? Well, last year we called it unbound behavior. So the one example is limit x approach 0 of 1 over x squared. This graph is going to look like this. But since it's not bounded, we're going to call that limit does not exist. But some people is going to say that's approaching infinity. Here's the things. In this case, you could have infinity or could be does not exist, but not both. Okay, so this is the case. Now, what is oscillation? Oscillation is kind of hard. So oscillation is going to occur at this function. Limits x approach 0 of sine of 1 over x. Now, does you guys know what a graph look like? Kind of, yeah, what Aiden is doing. But do you know why is that way? I'm going to use a t-chart. And y is equal to, in this case, sine of 1 over x. Now, I'm going to plug in a specific value. I'm going to plug in 2 over pi. What happens if I plug in 2 over pi? What happens if I plug in 2 over pi? What is sine of pi over 2 then? 1, good. How about 2 over 3 pi? -1, good. What is 2 over 5 pi? How about 2 over 7 pi? How about 2 over 9 pi? Good. Okay, so this is going to a what? 2 over pi, 2 over 3 pi, 2 over 5 pi, 2 over 7 pi, 2 over 9 pi. So is x value going to a what?
Going towards 0.
Y is going to a 0. This is a part that Ethan's really good at because abstract thinking, he has that skill. So it's going to 0 because the bottom gets larger, right? If bottom gets larger, what's going to go to 0? But if I go to 0, I'm going to oscillate in between 1 and -1. Right? So it's like this graph of sine of 1 over x. No. 1 over x. It's going to be like this. Oops. I can type. Okay, so that's like this. And remember last year I told you my mom beat me? Like back, forth, back, forth, back, forth. And it's getting faster and faster as I'm gonna go. That's for those of you, Raphael and Khrushchev, you don't know Asian parents, or you probably know Asian parents. But they don't slap you. They do? Good for them. Way to go. Huh? What did you say? You're too big. Too tall. She cannot reach you. So back then, like my mom used to do this to me all the time, and I was told, like, you know, when I did something wrong, she would slap me like a forehand like this way, and then I'll look away, and when I look away, she's like, "I'm talking to you. Look at me," and then she slapped the backhand, and I look at her. She's like, "Why you stare at me?" And then she the forehand. So it was like unlimited, just like back and forth, right? It was really bad. And this is what happened is in the here. It is strange, sorry. Okay, so what happened in here is as the things I assume that she have supernatural power, she's increased the frequency as it goes through a zeros. So she slap you infinite amount of time, and she slaps so fast, and all of a sudden you say stop, and she's gonna ask you, did I slap you backhand or forehand? And you're gonna be like, I don't know. I'm so confused because that's what happened in here, because it's going -1 and 1, -1 and 1. When it goes 0, it's going so fast that you cannot tell. If I keep on zoom in, what will happen, right? Cannot zoom in here. Yeah. So it basically just bunch of lines jumbling together. And that's what happened here. Okay, so that's oscillation. There you go. So there's 3 situations that does not exist. First is lemon from left does not equal to right. Second is unbounded behavior. Third is the whatever the oscillation. Okay, so we finished talking about this. Now we're gonna talk about graphic approach. So I'm gonna give you a bunch of questions. I'm gonna give you 1 question, long question, and ask you a bunch of parts of it. So this is a graph. And I'm gonna have something like this. Like there was an asymptote here, and there's an asymptote here, and this is gonna be here, and this open circle here, and so at here, there's an open circle this way, open circle, closed circle, open circle this way. What?
No, it's like arts and crafts. You're just putting random lines everywhere. It's like, oh, straight line here, curved line here.
No.
You can just take a picture of it if you want. Okay, so first question I'm gonna ask you is, hey, what happened when limits x approach to? Sorry, I'm gonna put a point here. What happened when limit x approach to 1, 2, 3, 4, 5, 6? What happened when limit x approaches 6 of f of x? If this is f of x graph. All right, you guys can count.
Shoot, wait, no.
Yeah.
Landon, what do you think? DNE? Khrushchev, what do you think? What? DNE, why do you think it's DNE? Does not exist. Ah, good job. Raphael, do you understand? Does not? So technically, I cannot answer this question until I find the other 2 parts, because it's reaching a single value. So you should always look at limits x approaches 6 from the positive. Well, what happened is limit x to 6 on the positive.
It's -1.
It's a -1 because as you see, I'm going to -1. Does that make sense? This is -1, right? If I'm approaching from the positive value, it's going to be +1. So C here, I can say limits x approach to 6 from the negative side of f of x is going to go +1. Therefore, because those two, due to those two, therefore this part does not exist. Is that okay? So what's f of 6? What's f of 6?
-1.
Yeah, it's
No, I did it too.
Wait, why is that not?
-6 is Raphael. What do you think?
Wait, -6?
What? 6, +6.
Oh.
-1 because you're looking for the solid dot. That's the evaluation. That means when x is equal to 6, what is the y value, right? Is that okay? Okay, so D, E, F. What happened when limit x approaching -infinity? I'm still not messed up yet. A, B, C, D. Oh, I did. I issued my first homework for pre-calc, and the Mr. Yeah, how come there's no number 7? I'm like, I can't count. I can't letter. I can't count.
Wait, approaching -infinity or?
-infinity, yes.
Yeah.
Shh, don't shout it. Don't shout it. I need Raphael and Khrushchev to understand. Raphael, what do you think? 1's good. Good job, Raphael. You're already gonna do better tests than Aiden now. By the way, Aiden last year, 25 times 25 is 7,025. 7,025. 7,025. I'm like, 07. I take a picture of it. Take a picture of it. What happened when limit x approached to 3? And what happened if f of 3?
Zoom in, por favor.
Yeah.
A, B, C, D, E, F, G, H. There's no D, but okay. G and H.
That does not look like a GDP.
You know what?
I'm sorry.
Also,
Can you zoom in?
Zooming where? Yeah, how we gotta say Asian? You're gonna have to squint your eye.
No. Because I was 2 behind when he
That's what I'm saying. It's a G. No, it doesn't have the loopy.
Yeah, you have to have
Yeah.
All right, so Khrushchev, what is it? Negative what? -2 and -6. Good job. So you know how to do it graphically.
Oh, there's another dot there.
Oh, it's -5, right? That's okay. I. What happened when limits as x approach to -2 from the left, and limit x approach to -2 from the right? And what happened when limit x approached -2? And what happened if f of -2? H, I, J, K, L. Yes, I can.
They are saying you're supposed to say that you are giving them a hard time.
Who?
So, plunge.
What? Grade change? I give everybody grade change already. You gotta ask Parati. Parati got a stack of paper this big.
I saw the stack of papers.
You did, right?
When I went to see Mr. Karate, I was like, look, those are all Mr. A's grade change.
It's not me now. I know he's pissed at me.
Yeah, I wonder why.
Huh?
Don't you do it every year though?
I piss everybody off.
I'm not used to it.
No,
I just work like 2 weeks out of the year. Everybody they school for the summer, they can't get anyone stuff straight, and then when you talk to them for 2 weeks, y'all gotta do your job, right?
Okay, -2 from the left. What's -2 from the left? Raphael? -3. What's -2 from the right? -1. What happened when limit x approaching -2? Does not exist. Good. Madison, what's f of -2? Does not exist also because there's no solid dots. Good job. So that's pretty much it. That's a pretty much extensive of thing. Now sometimes I can give you oscillation if it does not exist as well. So like to say if you have this, I have like going to here and that's going like this. Now you cannot tell what is that going to be. So you're gonna say that does not exist for that particular location. So because it's oscillating between two values. So very, very important for you guys to understand that. So therefore graphically it's done. Now, can I move on or no? Okay. What happened when limits, there's a basic limit C of B. What's limit x approach C on B? What is it going to be? Bless you. What happened when limit x approach C on B? What? The basic limits, come on. It's equal to what? B? Think of a graph.
Is B and C, they're just like,
Yes, they are constant. It's B. Why? Why, Tanner? It's a constant, but that's not why. Think of a graph, right? Think of a graph as a horizontal line. It's a straight line, yes. So we say B is, let's say B is 3. So B is equal to 3. So it doesn't matter what C value here or C value here, it's still always going to give you output of B. So therefore, limit x approach C, B is equal to B. That's the first limit. Second limit is limits x approach C of x is equal to what? C. That's it. Limit x approach to C of x to the n is equal to C to the n. So that's third.
This can equal negative use.
Nathan, shush. Whisper. Oh, you guys want to hang out outside? Oh, okay. I cannot talk over you. Though.
Get back up from x to the n.
Yeah, x to the n will be C to the n.
X to n.
Wait,
The straight U.
Got it? Okay, so imagine this. If I give you two situations, I say limit x approach to C of f of x is equal to L. It's a constant L. X approaches C of g of x is equal to k. And then you say, okay, well, what is the first property? It's called scalar multiple. Now you don't have to understand this, but limit x approach to c of b of f of x is equal to BL. The reason why it's equal to BL because you can take out a B outside the limits. And if limit x approach c of f of x equal to L, so therefore it's BL. So B can be taken outside. About limits, you can take a constant outside the limit. Just like integration, just like derivative, you can take the constant outside. So that's probably the most important thing here. The other one is all very self-explanatory. So limit x approach c of f of x plus minus g of x. And that's equal to L plus minus k. Duh. Limit x approach c of f of x times g of x. That's equal to L times k. Duh. Limit x approach c of f of x over g of x. Can you guess what is it? L over k. But k cannot equal to 0, however, because k equal to 0 is undefined. Thank you for your approval. Maybe Madison should run over you a couple more times. What happened when you go to court? Did you get resolved?
So I don't have to go. It
Oh.
still hasn't gone yet.
You haven't gone to court yet?
I don't think I'm going to.
Do you have a lawyer?
Yeah.
He's gonna counter sue you back. Be careful, Maddie. She's gonna sue you back today. You stand there, so she had to run over you. She cause her stress. Yeah, trauma. She had PTSD now every time she drives. Okay, so those are basic limits. Now we're gonna talk about finding limits.
Is that
X approach to C. Finding limit algebraically. First thing is your limits. You're gonna plug in the value. If you plug in a value and if you get a value, you're pretty much done. So for example, when limits x approach to 2 at 2x squared plus 3, you just plug in 2 squared plus 3, that's equal to 11. And if you got a value, you are done. But normally never get that, right? You never get 11 as a value. Most of the time, you're going to get a special case called 0 over 0. 0 over 0 is indeterminate. Good. I don't know how to spell indeterminate. I think that's what it is. Whatever, I just scribble. So if you're indeterminate, you're gonna do math. You're gonna be like, duh, what kind of math? Do math. First thing is factor and cancel. Second thing is combine fractions. Third thing is conjugate, which is we had to do it for the other one when it's radical. The fourth one is the absolute value. You have to do piecewise function.
Because that's the rate at which these two you let out once, and then say it is a fraction. Yeah, no. Well, alright, we're measuring that too, right? We know this, we know this, we know this, right?
Okay. Now we're gonna talk about this tomorrow or the day after. Is if you have a number over 0, there's other way you gotta do. So that first we're gonna talk about first thing. Limits x approach to -3 of x squared minus x minus 6 over x plus 3. Now, some of you guys gonna say, I'll just do El-Hubdo rule. Yes, El-Hubdo rule does apply, but El-Hubdo rule has limitations. We're gonna talk about when El-Hubdo rule has limitations. El-Hubdo rule has limitations, especially with radicals. Because the more you take a derivative radical, it's just gonna be more radicals. Okay, we're gonna talk about rest of tomorrow.
All the